Okay, figured it out. So there are a few knowns. So it's known that in beta oxidation we produce one FADH2, one NADH2, and one acetyl-CoA. We also know that in the citric acid cycle we use one acetyl-CoA to produce 3 NADHs, one FADH2, and one GTP. Well, oxidative phosphorylation is going to convert that one FADH2 into 1.5 ATP and one NADH into 2.5 ATP. And these will be given to you, but these are known amounts. It also is going to convert that one acetyl-CoA into these 7.5. The acetyl-CoA is going to be broken down into the 3 NADH, the 1 FADH2, and the 1 GTP to produce 7.5 ATP, 1.5 ATP, and 1 ATP. So then, if we're using this in one round of beta oxidation, again, we're going to produce the 1 FADH2, the 1 NADH, and then the 1 acetyl-CoA. Okay? In the citric acid cycle, which we just talked about right here, we're going to be producing that 1 acetyl-CoA into 3 NADH2, 1 FADH2, and 1 GTP. And then if we carry it all over in oxidative phosphorylation, which it should say oxphos right there, that's going to produce 1.5 ATP from the original FADH2, 2.5 ATP from the NADH, and then this 1 acetyl-CoA that was then in the citric acid cycle converted into the 3 NADH, that's going to convert into 7.5 ATP. The 1 FADH2 is into the 1.5 ATP, and then the 1 GTP is going to be the 1 ATP. So that gives us 14 ATP. Okay, so then with the question, if we have a 16 carbon fatty acid, we know that 16 divided by 2 is going to be producing 8 acetyl-CoA. And then 16 divided by 2 minus 1 is in 7 rounds of beta oxidation. So that's why you would say, you would take this FADH2 and NADH, and you would times that by the 7 rounds of beta oxidation, and that gives us our 28 ATP. But then, remember we had just our straight up acetyl-CoA that was produced, and so that's the 8 acetyl-CoA, and so that's where you'd take this 8, because the acetyl-CoA breaks down into this many ATP produced. And so then that number is times by that, and that's what gives you the 80. So then 80 plus 28 is going to be the 108. So basically, if you're given a fatty acid, this one was a 16 carbon, but if we had a 20 carbon fatty acid, 20 divided by 2 is 10 acetyl-CoA, 20 divided by 2 minus 1 is 9 rounds. So then you would take this 1.5 and 2.5 and times it by 9 rounds and give you that number. And then you would take these and times them by the 10, because that was the amount of acetyl-CoA that was produced when we broke down that fatty acid. So I hope that that was helpful. And so basically that is this formula just broken down. Okay? So let me know if you have any questions. I know that's foggy. There we go. So there you go. So the top number is the rounds of beta oxidation, and that's why we times it by that. And then the bottom number, the 8, is the number of acetyl-CoA that would be produced in that fatty acid breakdown.